This screencast is intended to help you learn how to draw celestial spheres for the sun's path, and in this particular case we're going to be looking at the location of the North Pole, 90 degrees north. We are going to start with the equinox date, and to find your angle of insolation during an equinox, you take 90 degrees minus your latitude. So in this case, 90 degrees minus 90. Don't tell me what the answer is. 0. So the sun will be at the horizon the entire time. And if we take a look at a starry night, we can see that here the sun is going to rise exactly in the east. I apologize, I had it set for the wrong location. So we take a look, we're going to make this 90 degrees north. And we're going to see it's going to rise, go back in time a little bit. It's going to rise exactly in the east and stay along the horizon the entire time, and then it's going to set in the west. And that's going to take it 12 hours to do that. So we have 12 hours of daylight, 12 hours of night on that particular date. So I would show it by rising sun exactly east, setting sun exactly west. Solid line for rising sun. And once I get past this point, it's going to be, that would be my setting sun. By the way, in either direction, it would be south because we're at the North Pole. So that would be for March 21st, September 21st. June 21st we'll do next, and you'll see why in a minute when I get back to December 21st. But if we take a look at June 21st, starry night. Let's change the date to June 21st, and we'll change the time to, not that it matters, let's everything be equal here, 6 a.m. Kind of the cool thing, I can just kind of scan the sky for the sun. Hey, there it is. And watch when I hit play, the sun, if we follow it, does not appear to rise or set at all, but instead circles the sky at the same altitude the entire time during the entire day for June 21st. Now if we take a look at this little simulation that we've done so many times, that would be this orientation for June 21st. You could see that the sun's rays, it's not possible for the sun to rise or set at the North Pole. They go straight across, and the North Pole is in 24 hours of daylight. The sun circles the sky on this particular date. Kind of cool, right? So how would we draw that? Well, we take a look at our equinox angle of insolation. We see it's 0. We know the sun's going to get higher in the sky by 23.5 degrees, so we're going to go 23.5 degrees this way, make my little mark, 23.5 degrees this way, make my mark, and now I do solid for, not that there's a rising and setting sun in this case, because there clearly isn't, but just to kind of give it some dimensional space, and then I take my date and put it there. June 21st. You might want to put it there, or there, but definitely not here, so there. Now let's take a look at December 21st. I'm going to switch it up a little bit, go back to this animation, and then you could see that if I go to December 21st, here, you can see that it's not possible for the North Pole to go into light at all. Therefore, it is 24 hours of darkness. As a matter of fact, if you go back in time, anything after September 21st, and you can see right there, the North Pole just starts to turn into darkness, and it will not see light again until, that's right, March 21st is when it starts to rise again. Kind of depressing, right? So, that's pretty easy to draw. Let's just show you in starry night, though, what that would look like. And let's just change the date to, in this case, it would be 12/21. It's at 22 right there, but we'll just make it 21. And I could just hit play. The stars and the moon still appear to rise and set because the Earth rotates on its axis, but there is no sun. The sun never gets above the horizon. It's below the horizon. So, the way how we would see that, it would be drawn like this. It would be below the horizon. So we don't have to worry about putting the December path on there at all, or some people would say at all. So these are the dates that are very important, and you need to know that on these particular dates, June 21st, the sun's rays are directly overhead at the Tropic of Cancer. For all locations, it appears to rise north of east and set north of west, the exception being anything north of the Arctic Circle, or anything south of the Antarctic Circle where it doesn't rise at all. March 21st, September 21st, for all locations on the planet Earth, it rises exactly in the east or due east and sets exactly in the west. December 21st, over the Tropic of Capricorn, it rises south of east and sets south of west, the exception being anything south of the Antarctic Circle or anything north of the Arctic Circle, where it doesn't rise at all for the north of the Arctic Circle. South of the Antarctic Circle, it doesn't set, so just they have 24 hours of daylight there. And still no answers for the purpose of this. Baffles the mind.